In this video, we are going to examine 5 Chapter 8 exercises. Provide the UPAC name of the following compound. So here we have an alkene, it's disubstitute alkene, with bromine and chlorine atoms being the substituents. So first, when we consider the parent chain, there are 6 carbons, that would be hexane. Since it's an alkene, then suffix is -ine, so it's hexene. And double bond is between carbons 2 and 3, so that's 2-hexene. On carbon 2 substituent is bromine, and carbon 3 substituent is chlorine, and alphabetic order is bromo-chloro, so this is 2-bromo, 3-chloro, 2-hexene. Finally, we have to determine stereochemistry, whether it's E or Z. It is E. Higher priority substituents, 2 halogens, bromo and chloro, are on the opposite sides of double bond, so it's E, 2-bromo, 3-chloro, 2-hexene. How many degrees of unsaturation molecule C5H5F3 has? So to calculate number of degrees of unsaturation, we start with number of carbon atoms and how many hydrogens and halogens saturated molecule would have. And trick here is what a lot of students omit is to take into account number of halogen atoms. Fluorines, chlorines, bromines, iodines. They are added to the number of hydrogens. So calculation should be 2 times 5 plus 2. That's 2 times number of carbon atoms plus 2, which is total number of hydrogen atoms that saturated hydrogen and halogen atoms that saturated molecule would have, minus number of hydrogens and halogens. So 5 hydrogens and 3 halogens. And that's all divided by 2. So 2 times 5 plus 2 is 12. So saturated molecule would have had total of 12 hydrogen and halogen atoms, minus the actual number of hydrogens and halogens, 8, divided by 2. So 12 minus 8 is 4, divided by 2 is 2. So this molecule has 2 degrees of unsaturation. It means it has 2 rings, or 2 pi bonds, or 1 ring and 1 pi bond. What is the UPAC name for the following compound? This is a diene, and parent chain has 7 carbon atoms. So that means it's going to be heptadiene. We number it in such a way that substituent, in this case methyl group, has the smallest possible number. That's because numbering from left to right or right to left gives the same set of numbers for 2 double bonds, and that's going to be 2, 5. So double bond on the left should be double bond 2, that gives number 3 to methyl group. So it's going to be 3-methyl 2,5-heptadiene, and then we have to indicate for each double bond, so here numbering is shown, we have to indicate for each double bond whether it's E or Z. So it's 3-methyl 2,5-heptadiene, and then individual double bonds are E. That's because higher priority substituents in each case are on the opposite side of double bond. So for each pair of substituents, we have to determine priority order. In general, in most cases, 3 of the cases, except for carbon 3, but for carbons 2, 5, and 6, it's carbon versus hydrogen. And so for double bond 5, 2 carbons are on the opposite sides, high priority substituents, that's easily determined to be E. In case of double bond 2, on carbon 3 we have 2 carbon atoms, but you can see that this priority methyl group versus methylene CH2, which has additional carbon attached to it, so that's higher priority. So 2 higher priority substituents are on the opposite sides, and therefore that's also E double bond. So correct name is 2E, 5E, 3-methyl 2,5-heptadiene. How many isomers of the compound above question 3 are possible? Total number of isomers are 4. 2 to the power of a number of double bonds, and that's the maximum number of isomers. Number of would have been fewer if molecule contained symmetry. But this molecule has no symmetry. 3-methyl group breaks any symmetry in the molecule, and so the number of isomers is 2 to the power of number of double bonds, to the power of 2 or 4. And finally, question number 5. What is the UPAC name of the following compound? This appears to be at first glance another diene, but it is not, because 2 double bonds are in a way considered separately, because 1 double bond is part of the parent chain, cyclopentane ring. Since cyclopentane ring contains double bond, it's cyclopentene. Double bond has numbers 1, 2, and number 1 is assigned numbers 1, 2. Number 1 is assigned to carbon that carries a substituent. Substituent is vinyl group. Hopefully you recognize that double bond as vinyl substituent. So the actual name is 1-vinyl cyclopentane. So the trick here was first to identify that 2 double bonds are not considered part of a diene system for naming purposes, that actually 1 double bond is part of the parent chain and the other double bond is part of the substituent. And then name the parent chain, cyclopentene, and substituent to recognize that it is vinyl group. So this completes chapter 8 exercises.